Hello students, today we are going to learn a topic on handling uncertainty. A person is said to be intelligent if the person is capable of dealing with different uncertain things. So uncertainty, ability to handle uncertainty is a kind of intelligence, and when uncertainty is handled by computer systems, we call it as artificial intelligence acquired by the computer system. Now, so far we have discussed about knowledge representation, predicate logic, propositional logic to represent the knowledge, and we also learned how different kinds of problems can be solved using inferencing. Different kinds of inferencing mechanisms we have already discussed. But all this put together is handled in a certain environment. With 100% certainty, we are able to say certain things so that we will be able to handle using the knowledge that we have acquired, and also solve different kinds of problems using propositional as well as predicate logic. But there are so many things in the life that we cannot say with 100% certainty. Whether will it rain in the next moment, we will not say with 100% certainty. Therefore, there are so many situations where there is an element of uncertainty, and we need to consider the uncertainty that is there into the system so that we will solve different kinds of problems where uncertainty is very much prevailing. In first order logic, we are using knowledge based agents, right? Knowledge based agent will have the knowledge about the environment, because percepts are taken from the environment which are processed to actually control the environment through actuators. But in first order logic, agents, in some situations, in some applications, agents rarely have access to the truth about their environment. Sometimes we will not be knowing, while we are in a room doing something, we will not be knowing what is happening outside the room. Okay, uncertainty can also arise because of some incomplete information or incorrect information, lack of understanding of the agent regarding the environment. Considering all these things, the issue of uncertainty is expected to arise. For example, in the case of predicate logic, see this predicate logic expression. For all values of P, whenever there is a toothache symptom, it implies that there is a cavity. So, it is not necessary that cavity is required to get a toothache. There could be thousands of reasons why toothache can come, and it is not necessary that cavity alone is going to create this toothache. So, this, even though in the predicate logic this clause is right, but in general there is an element of uncertainty associated with this. And you can change this predicate logic in several ways. You can include different kinds of diseases which may lead to toothache. Like toothache implies there could be a disease in cavity, there could be a disease in gum disease, or there could be a disease on impacted wisdom teeth. Because of all these reasons, there could be an element of toothache. But expanding, even the symptoms, the disease, several thousands of diseases can be included which lead to a symptom of toothache. Even if that kind of generalization and expansion, unlimited expressions are required, and it is not feasible to write predicate logics in that manner. I will give you an example here related to uncertainty. Okay, let's go ahead and define uncertainty. Uncertainty refers to the situations involving imperfect or unknown information. It also implies predictions of future events based on physical measurements that are already made as on today. And generally, the issue of uncertainty is because the partially observable or stochastic environments. When we are unable to fully observe the environment, and when there is a situation of partial observability about the environment, then because we will not be knowing everything related to that environment, there could be an element of uncertainty. We will be acting only to the extent that we can observe. But what about those things that we are not observing? That is an issue. Because we cannot observe everything, there is an element of uncertainty. So uncertainty is bound to be there in every, whether you are taking input or whether you are processing something, or when you are trying to output some output to the environment for control purposes. Generally, people may have ignorance, indolence, or both. Because of all these reasons, there could be, see, but suppose we don't know something and something is happening, and without knowing that, suppose we act, then that also leads to an issue of uncertainty. Uncertainty is very much there in so many fields like insurance, philosophy, physics, statistics, economics, finance. Suppose in stock market, there is an uncertainty of what is going to happen about the stock value. Psychology, sociology, engineering, meteorology, and so many fields, this issue of uncertainty is very much prevailing. So what? So there is an element of uncertainty. How do we compute? How do we measure the uncertainty? Generally, uncertainty is computed or represented in terms of probability of occurrence. So probability theory comes into the picture here. We will a little bit discuss about probability theory. So uncertainty is computed in terms of probability, and the value of uncertainty is always ranging from 0 to 1. 0 means completely uncertain, 1 means certain. Anything between will give you the percentage of uncertainty. So uncertainty is measured in terms of probability of occurrence, and the value is measured in between 0 to 1. 0 implies completely uncertain, 1 means completely certain, and 0 to 1 means a percentage of uncertainty related to different occurrences of events. Suppose you have a coin, and in the coin you have two faces, one is head and tail. Suppose when somebody is flipping a coin, what is the probability that head is going to come? Because there are two possible outcomes and we are expecting only one favorable outcome. So possibility of head coming out of two phases is 1 by 2, which is 50% probability that when you flip a coin, you will be able to get a head. Same is the case with the tail. So this is how it is computed as number of favorable outcomes divided by total number of possible outcomes. That is how probability is computed, or probability is a representative of uncertainty. Therefore, uncertainty is computed in terms of a small computation, favorable outcomes divided by the possible outcomes. In the case of coin, it is 1.2. The probability is again understood to be of two types. One is called as prior probability, and another one is called as posterior probability. Prior in the sense we know already the probability of, for example, probability of a coin is 0.5. We know it, or probability of a face of a dice is 1 by 6, because there are 6 possible outcome. We are expecting only one outcome. So the probability of getting a particular face on the dice is 1 by 6. So when such kind of situations are there, we can very easily know right in the beginning. Then we call it as prior probability. Second one is called as posterior probability. Posterior probability is also called as conditional probability, and this probability is computed based on the occurrence of a particular evidence. Okay, what is the probability that a student will write the exam provided exam date is declared? What is the probability? So declaring exam date is a event to happen. Given that condition, then you can compute what is the probability that a particular student will be writing the exam. So posterior probabilities are called as conditional probabilities, they are based on occurrence of a prior event. Already there should be an event that has happened, which is given as a condition. Given that condition, what is the probability of some other event to happen is computed through posterior probability. Now there is also another important issue called as probability distribution. This is also a fundamental concept. We will discuss about probability distribution a little later. Now some examples of unconditional probability or prior probability is given as, suppose probability of a person having cavity is 0.2. So this is, suppose we say that 20 people out of 100 will have cavity, then 20 by 100 you can take as 1.5 or 0.2%. So the probability computations can be done based on the data that we have quite ahead. So different probability of a head coming in is 1/2, which is nothing but 0.5. Okay. Similarly, probability of a tail to come in a head rotation is also 0.5. So unconditional probability or prior probabilities which can be computed based on the data that we collect in the real life. And the probability, as I said, will be in the range of 0 to 1. 0 means completely uncertain, 1 means certain. Probability of true is 1, probability of false is 0, probability of A union B, these are all called as axioms. So you can, there are so many axioms readily available which you can take them for advantage, and for various kinds of interpretations you can consider these axioms. So P of A union B is P of A or P of B minus P of A intersection B. Like this, you can go into so many other axioms that are available in probability theory. Now coming to the probability distribution, if there are 6 possible outcomes, for each outcome what is the probability? If you put all of them together, then this is called as the probability distribution of rolling a particular dice. In dice there are 6 phases, 1, 2, 3, 4, 5, 6. Each phase the probability of occurrence is 1/6, because there are 6 phases, 1 is one among them, so 1/6. Similarly, all the remaining phases, they are, have their own respective probability, and if you put all these probabilities in sequence for each of the possible outcome, then we call that this is probability distribution. Now I am giving you, there is something called a joint probability distribution. Sometimes P of A, P of B are single variable based distributions, but sometimes uncertainty can also happen due to joint occurrence of more than one variable. For example, what is the probability of season and weather? When the weather is either sunny or rainy or cloud or snowing, and the season is either spring, summer, autumn or winter. Now what is the probability that it will be sunny in spring is given as 0.07, and what is the probability that it will rain while being in spring is 0.03. Like that you can compute all probability, and the probability of the spring is given as by addition of all individual attributes that you considered here, adding you get the probability of spring, probability of summer, probability of autumn, probability of winter. If you add up all of them together, all season probability of all seasons, you will get 100. Probability of all weather conditions, if you add, it is 100. 100 in the sense it is 1.0. So always the maximum probability that you will be able to get is 1.0, and individual elements of that probability will be less than 1.0 and greater than 0.0. So if you add up the probability of spring, summer, autumn, winter, you get 1.0. Similarly, probability of sunny, because if you add them, weather should be either one of them. So when you add the probability of all of them, you will be getting 1.0. So P of sun plus P of rain plus P of cloud, P of snow is 1.0. Okay. So, what is the probability that the season is summer? Season is summer, and weather is sunny. Sunny means here summer sunny. The value is 0.13. So, joint probability distribution means the probability of occurrence both the variables happening at the same time, of course with the different values. That is what is called a joint problem. In a problem area, there need not be only one parameter, one variable. There can be n number of variables. Generally, that is the case when it comes to the machine learning or deep learning. Data, input data will have different features. For example, in this data which I have considered, I have taken two variables. One is season, another weather, and season has several values: spring, summer, autumn and winter, and weather has several values like sunny, rain, cloud and snow. For combining for any pattern of data assigned to either season and weather, we need to compute the probability of occurrence of those events. Then it is called a joint probability. If you look at this figure, there are two variables A and B. The intersection of A and B, suppose it is given 0.1, the probability of B and not A is given as 0.09, and probability of not B and A is 0.63, probability of not B and not A is given as 0.17. So, not means if A, not occurring A is minus A, occurring A is A. Similarly, occurrence of B is given as B, and non-occurrence of B is given as negation of B. Now, from this table, P of A intersection B is given as 0.11, P not A and B is given as 0.09, P A and not B is given as 0.63. From this, probability of occurrence of A can be computed, because probability of occurrence of A is P of A intersection B plus P of A and not B. If you add those two things, you get the probability of A. Similarly, you will get probability of B with the help of probability of A intersection B, meaning probability of occurrence of both of them together, and probability of non-occurrence of A and occurrence of B is probability of B. If you add, you will get the individual probabilities of both the events, even though they jointly occur together. There is another important concept that you should know: probability density function. Now, most of the variables that you call as stochastic are random, and they are called as also discrete. Discrete means only one value you will be able to assign at any point in time to the different variables. Whereas there are situations where variables are continuous in nature, and computing probability of that continuous variable is not easy, and therefore there are situations where what will be the probability of occurrence of a variable having a value ranging between two limits. Like for example, what is the probability of A in the range of A and B? Okay, probability of X which is in the range of A and B, while A is the lower limit, B is the upper limit. This kind of situations will come when there are continuous values assigned to the variables. Okay, this is also called as interval. F of X is called as density function. What is the probability that a particular event will happen in a particular range is given by F of X. D of X is the lower limit, upper limit range. So, density probability density is computed. Probability of occurrence of a variable in a particular range is computed using an integral equation here. A to B, which is A is lower limit, B is upper limit, F of X is a probability density function, D of X is the derivative of it, which is the range difference as shown here. Suppose you have a problem that a clock stops once at a specific time, then let X be the time at which the clock stops. What is the probability that the clock stops in between 2 p.m. to 2:30 p.m.? Now, let us actually define density function. F of X is equal to 1 by 4, 1 by 24 here, 1 by 24, okay, for when X is in between 0 to 240. If x is above 240, suppose it is given as a 0. So our probability density function, considering different kinds of ranges, the range that is taken here is 0 to 240. Then because there are 24 hours in a day, 1 by 24 will be the density value of that particular function, and anything after 240 it is going to be 0. So if for you to compute what is the probability that x will be there in between 14 hours to 14.5 hours, then you can put integral of this f of x ds. You know f of x dx is 124 because this is within 240. So and the dx value is the difference between the upper limit and lower limit, and when you do it you get a value this, and this is the probability that a particular variable occurs in between a range of 14 to 14.5. Like this, some variables will have to be computed with the probability of occurrence given a range value with a lower limit and upper limit, in which case you will be able to compute the probability in this manner. Now, in literature for handling uncertainty, there are three different approaches given, and basically uncertainty handling is very heavily contributed, managed, and lot of methods were recommended by a professor called as Bayer. So the three approaches he has suggested, recommended, which are being regularly used even today: Bayer's theorem, Bayer's naive classifier, and Bayer's network. Three different ways have been proposed to handle the uncertainty. So let us go one by one and understand what it is. Now let us see the very first one, the Bayer's theorem and classifier. Now in logic, A implies B you give, and probabilities are expressed in a notation similar to that of predicates in first order logic, order predicate calculus. P of R, so probability of raining is 0.7, probability that it is sunny is 0.1, probability of A or B and say not is 0.2. Like this, with the available data, different kinds of probabilities can be defined, and certainty is given as 1, as I already said, and not certainly can be given as 0, which is the uncertainty. Bayes has, I already told you, prior probability and posterior probability. When probability values are given with the known knowledge and available data, then it is called as the prior probability. Like probability of raining 0.7, these kind of probabilities are called as prior probabilities. Then the second method of probability is called as conditional probability. Conditional probability implies probability of something happening given something has happened. For example, what is the probability of B given that A has happened? That can be computed by way of probability of B intersection A divided by, this is P of A. So P of B by A is equal to P of B intersection A divided by P of A. This is also given probability of B given A. P of A must be given in order to compute P of B by A, or P of B intersection A must also be given. So conditional probability here is that P of A is given and P of B intersection A is also given. Then you are able to compute P of B given A. Probability of occurrence of B given that A has occurred can be computed by using this particular expression. Now you can take different kinds of example to understand this. Suppose the probability of raining represented by R is 0.7, probability that it is sunny is represented by 0.7, probability that it will rain on a sunny day is P intersection S. That means it should rain and it should also be sunny is given as 0.01. And now we want to compute what is the probability that it will rain given sunny. Now P of S is 0.1, P of R intersection S is 0.1, P of R given S according to Bayes is P of R intersection A S divided by P of S. P of R intersection A is given as 0.7 and P of S is given as 0.1. So when you do it, you get 0.1. So prior conditional probability values can be computed provided some particular occurrences, evidences are prior noticed. Using them, posterior probabilities can be computed, meaning the one which is not known can be computed with the known aspects as per the Bayes theory, and it is proved to be extremely right. So Bayes theorem, let us calculate conditional probability. So this is the equation. So P of B is a prior probability. So P of B by A is a posterior probability. Now you can take another example, that is medical diagnosis using Bayes theorem. For example, meningitis causes stiff neck 50% of time. You see that most of the time lot of people wears a band across the neck. That is because of a disease called as meningitis. Okay. So what is known to us is out of 50,000 people, there is one person who will have meningitis. And the probability that a person will have a stiff neck is 1 in 20. Out of 20 persons, one person may have a stiffing neck. Now the question is, given that a patient is having stiff neck, suppose somebody is having stiff neck, what is the probability that he has a disease called as meningitis? So that is computed P of, but what is given here? P of S, probability of a stiff neck given meningitis is 50% of time that situation is given as input, so it is 0.50. Probability that there could be meningitis, 1 out of 50,000 people can have this disease and 1 out of 20 people can have stiff neck. This is the data that is given. From this data we need to compute what is the probability that a person has meningitis disease given that he has a stiff neck, which is nothing but P of S by M into P of M divided by P of S. You put the value, you will be able to calculate the probability. So in using Bayes theory, from known information we are able to find unknown information, that to probability. Please, 100% you cannot say, it is the only 20% of the, for example, this is the value, probability value, and if you divide this by see, it's so negligible value 0.0002, which happens in between 0 to 1. So the probability that somebody will have a stiff neck given that he has a disease of meningitis is very, very small. So the severity of the diseases, severity of the treatments being given can be very easily be estimated by using Bayes theorem. Now Bayes theorem could be computed in two ways, as I said. P of B given A could be computed through P of A given B and P of B divided by P of A. This is one way. Another way is P of B given A can be computed by taking P B intersection A divided by P of A. So both are same in all the respects. Either you can compute this way or this way, depending on what kind of data you are given with. There is one more example here is about medical diagnosis. The data given to you is 80% of time you have a cold and you also have a high temperature. Okay. Then at any time 1 in 10,000 people has cold and 1 in 1,000 people have a high temperature. Suppose you have high temperature, what is the likelihood that you have cold? That means what? Suppose temperature is represented by T and cold as C. What we want is, what is the possibility of a person having a cold given that he has high temperature, that is represented as P of C given T, which is nothing but P of T given C into P of C divided by P of T. So, whatever data that is available here, when you apply, then you get 0.008. So, the possibility that somebody will have the cold given temperature, high temperature, is only 0.008, which is negligible. But but the uncertain situation, somebody may have cold or may not have cold, with the probability, that is uncertainty issue, is handled through probability. So, you can compute that kind of situations through probability expressions, and you can very easily say probability that a person will have cold given temperature is only 0.008. Sometimes it is considered as a negligible value. See, one more example which you may have to solve at your end. Suppose somebody has hit and run incidents has happened, and when somebody is hitting and moving, there can be an eyewitness where you will be able to get input from them which type of car, the car that is being hit, is it a white car or white taxi, which type of taxi is this. When you want this kind of inquiry, this kind of probability theory will be very helpful. The lady, suppose, is watching that somebody is hitting another object and moving away, and you go and ask the lady, what type of car is this, what color of the car is this, and if she says with 75% accuracy, how do you estimate which type of car has hit? The facts that are there with her: a company has 90 yellow cars, a company has 10 white cars. Expert says that given a foggy weather, the witness has 75% chance of correctly identifying the taxi, whether it is white color or yellow color. So, suppose of 90 yellow cars, she will say 75 are yellow cars and 23 are, because 75% is the accuracy. Similarly, out of 10 white cars, 3 cars are yellow and 7 cars are white. What is the probability of woman saying white? How likely is she right? Now, you can put a probability theory of Bayes theory into this and come out saying that the probability that the lady is correctly identifying the car that is hit could be expressed. There is what is called as relative likelihoodness. This is another important thing. Of course, this is only relative. Suppose there is a medical diagnosis, probability of somebody having cold is this, probability of high temperature given cold is 0.8, probability of occurrence of a plague is 0, this is a big number, small number, and probability that a person will have a high temperature because of plague is 0.99. Now, you can compute what is the probability of person having cold given high temperature. You can compute, and you can also compute probability of plague given high temperature, and the relative comparative values of both of them will tell due to what reason the high temperature has come, and in which case it is more likely. More likelihood means is the temperature because of cold, is the cold because of high temperature, or is it because of plague? Because a person has high temperature, is it because of plague or it is because of cold? Which is the main reason? If you want to really assess, then relative likelihood computations will be far better. Now, generally, when it comes to the corona or when it comes to the cancer, the judgment is based on the test conducted on an individual. The test may give either correct result or sometimes it may give incorrect result. Then how do we know? Suppose somebody has done with a corona test, it comes positive. How can we certainly say that he has corona or not having the corona? Similarly, whenever the test comes negative, how do we know whether he doesn't have the corona or he has the corona? So these are dilemmas, uncertain situations. Even though test is done, based on the test result, we will be in real dilemma of really person is having a specific disease or not. Such kind of situations can be very easily solved by using Bayes theory. For example, a patient takes a lab test and the result comes back positive. Test returns a correct positive result in only 98% of the cases. Correct negative result, suppose there is no corona and the negative result comes, is about 97% of the cases. Furthermore, only 0.008 of the entire population has this disease. This is the basic data being given to you. Based on that, you need to estimate what is the probability that this patient has cancer or does not have the cancer, and what is the diagnosis. You can compute, calculate the probability that the test will be positive, and what is the probability that the person has a cancer given the test case. For example, P of cancer is given. P of cancer is given means P of no cancer also is computed, because always some positive negative values can be obtained by subtracting positive values from 1. Okay, P of no cancer is 1 minus 0.001, which is the P of cancer. So P of no cancer will be this much. Now the test is given positive. What is the possibility that the test will be positive given that a person has cancer? That is given as 0.90. What is the probability the test will be negative given the person has a cancer? Obviously it is 1 minus 0.90, which is 0.10. Similarly, if you go and look at what is the probability that a test will be positive that a person has no cancer, and what is the probability that the test is negative given the person has no cancer, can be computed. Okay. Now if you look at what is the probability that the test will be positive, now that conditional probabilities are given, we want to compute what is the probability that the test will be positive or what is the probability that the test will be negative. So test will be positive is given as test positive given cancer into P of cancer, because that is the conditional probability, plus P of probability that the test will be positive that there is no cancer into probability into no cancer. If you do it, you will get the probability that the test will be positive, you will be able to get. Similarly, you can compute P of cancer. Now that the test plus is computed in this manner, what is the probability that a person will have cancer given test plus, which is nothing but P of test plus given cancer into P of cancer divided by P of test plus. If you get, then what is the probability that a person will have cancer is 0.08, which is 82.5% given test is positive. So with all the data that you get, you can get P of test, what is the probability of test being positive, and then given that there is cancer and given that there is no cancer, and then compute the test result, probability of the test, then you estimate the probability of a particular disease being there. Like that, both positive side and negative side you can take, and considering them you will be able to use Bayes theory to compute the probability of occurrence of cancer given a test result can be computed in this manner. Not only cancer, even corona, any damn disease where testing is done, positive results are given, and you are given with the data, 100% with accuracy you will be able to say whether a person is really having a particular disease given the test result. Now next one, that is what is called as Bayes theory. Bayes theory can be used, Bayes conditional probabilities can be quite frequently used to estimate the probability of occurrence or predicting the probability of occurrence of certain diseases. I have shown you so many examples now. I have given a cancer example, and I have given the high temperature, cold and plague situation. I have given witness hit and run cases, and I have given some medical diagnosis related examples. So many examples were given to you from which you can understand that Bayes theory can be conveniently be used to estimate the probability of occurrence of particularly certain diseases, especially in the medical fields. Then, at any point of time we are only talking about, a specific disease, but generally if you look at the data that we have in a particular situation, there can be several features in the data, not necessarily one variable, there can be several variables in the data. I can give you several examples to you. There could be several reasons why cancer will come. Suppose there are 4 attributes. Then the 4 attributes put together is called as data, and occurrence of cancer is called as the classifier. For example, if you take this equation, probability of occurrence of data given H, meaning given some class is given as, see these are all attributes A1 to A8, and the given thing is occurrence of a particular event. That can be computed by a projection of individually for each of the feature for a given hypothesis, that is occurrence of an event, you compute the probability and multiply all of them together in order to get the overall value for considering the entire data set as a whole. Okay. So it is Bayes classifier is a mechanism to classify a set of data containing several number of attributes to be belonging to a particular expected outcome. That is what is called as classifier. For example, in a class I have few students, I can classify them into A plus grade, A grade, B plus grade, B grade, like that. I can classify them based on CGPA, and also maybe based on their attendance, based on their CGPA, based on their promptness, and based on many other attributes also. Probably you can classify them to good student, excellent student, bad student, something like that. You can classify all the students based on the attribute value of the students. So like that, there are many applications where you need to do the classification into different categories based on the attribute values. In that case, this naive Bayes classifier will be very handy and useful. And suppose you have several examples. For each example you compute a probability. Suppose there are 10 examples, you compute 10 probabilities, and out of them whichever is the maximum that you get, and that is the probability of occurrence of that particular classifier. That is because in a data set, with 4 features there can be 10 records. For each record you can estimate the class to which it belongs, because all of them belongs to the same class. For each of them the probability could be different. Then we need to pick up only the probability of an example which has got the highest posterior probability for estimating the class. Now I give an example here for you to understand classifier. Suppose you collected this data. Suppose the 14 days of data is collected, and you have witnessed the weather conditions like outlook, what was the temperature situation on a day, what is the humidity situation, whether there is wind, whether we can play tennis or not, whether people have played tennis or not. No means they have not played, yes means they have played, and you collect all this data. This is all called as example set. This is example 1, these are example 4. For each example you are dealing with 4 different attributes here: outlook, temperature, humidity, wind. For each of the attribute you have different values, and on a particular day for each of the 4 attributes with different values, whether they have played tennis or not. Here the classification you are doing is, given the attribute values, should you play tennis or not. Here the output classification is either no or yes, only the 2 classes, whether you play or you don't play. and the attribute having different values, you have already collected whether the class of that is whether to play tennis or not on that particular date. Now, having this kind of data with you, you will be able to predict, given any set of values related to outlook, temperature, humidity and wind, you will be able to determine whether one should play tennis on a particular date or not. Now, based on the example in the table, let us classify and say whether we will play tennis or not, given that outlook is sunny, temperature is cool, humidity is high and wind is strong. And these are the attribute values we are giving, because we can observe all of them, they are evidences. We need to determine whether we should play tennis or not. So, the classifier value is computed as probability that somebody can play the game or not game is given as maximum of P of x. P of h here is the hypothesis. Hypothesis is either play tennis or not play tennis. There are only two hypotheses here. So, P of h into P of for each of the attribute you need to compute, given that play tennis is yes. The what is the for the x is a variable here, but there are 1, 2, 3, 4 variables here. So, for each of the variable given the hypothesis, you compute the probability, multiply them and further multiply with the probability of the hypothesis, then you will get the probability of the Bayes classifier, the class to which the particular data belongs, whether to play or not to play. Okay. So, the same thing, because it is P of ai by h. Now, ai are 4 attributes, outlook is sunny given h, temperature is cool given h, P of humidity given is equal to high given h. So, because there are 4 attributes and P of ai by h is divided into 4 attributes, and multiplying their probability with P of h is hypothesis. Now, probability of played tennis is equal to is 9 by 14, because out of 14 days there are 9 records which says that the tennis must be played. Therefore, P of hypothesis, which is play of tennis, is equal to S, is given as 0.64. Similarly, out of 14 days, 5 days it is given as not to play tennis. Therefore, probability that tennis is equal to no is 0.36. Similarly, probability that wind is equal to strong given play tennis is equal to yes is 3 by 9, because there are 9 cases where play tennis is yes, and out of those 9 days wind is equal to strong is only on 3 days. So, P of wind is equal to strong given that play tennis is equal to yes is 3 by 9. Similarly, P of wind is equal to strong given that play tennis is equal to no is 3 by 5, which is 6.0. Like this you can compute, and then finally the two expressions can be computed. Probability that to play tennis is yes is computed to 0.053, and probability that no play of tennis is given, that sunny is no, cool is equal to no, strong is equal to no, then it is 0.0206. In this case, play tennis is get a probability value higher than this, then you take a decision that yes, we can go and play the tennis. So, this is about Bayes classifier. This is a second way of computing uncertainty, especially using joint probability distribution, where there are several number of variables. In the Bayes case, we take only one variable or two variables and combine them to find out the value. But whereas in the case of joint probability distribution, we take several number of values and compute the conditional probability to answer different kind of queries to estimate the probability of some event that we can take it up or not. The third approach is using I said there are three techniques. One is Bayes' theorem, second one is Bayes' naive classifier. The word naive implies there that all the variables which are there in the database are independent and there is no relationship between them. Naive means it is a kind of an assumption that variables which are there in the database, they are independent and there is no connection between them. The third aspect is about the Bayes networks. We'll show you the network. What is the what is this kind of model? Here, think that there are several attributes A1 into AN, and each attribute has got different kinds of values that can be assigned, which is the case even in the joint distribution. Now, a different approach is being suggested here, that a set of links or arrows, a pair of nodes will get connected, can be connected, provided one is the parent of the other. Each node has a conditional probability CPT that quantifies and indicates the effect of the parent have on the node. So, the graph is a directed. So, what we are trying to do is, because this is a network, we are trying to establish a network among the variables, and the variables can be assigned with the values, and conditional probability of each variable is computed based on the parents of that particular variable. I will see this particular network. You see, there are burglary is one variable, earthquake is another variable, alarm is another variable, John calls is another variable, Mary calls is another variable. Now we connected burglary and earthquake is connected to alarm, and alarm is connected to John calls, and Mary calls we have connected, and this is called as the Bayes network. And for each of the node we provide their probability values. The probability of burglary happening is P of B, the probability of earthquake is happening this, and probability of alarm happening is based on the parents. Here the parents is burglary and earthquake. Now P of B, burglary could happen or may not happen, earthquake may happen, may not happen. So if both of them true, then P of A, that alarm coming up, given that B and E has happened, when both of them are true, is 0.95. When one is true and another false, it is 0.95. Another is false and like this. This is called as conditional probability table. We can develop conditional probability table for each of the variable here based on its parents. Here the parents for alarm is burglary and earthquake. Similarly, the parent from John calls is alarm, the parent for Mary calls is alarm, and John will only call when there is alarm. Given that there is alarm, John will call. Okay. Now alarm is true means P of j given A is 0.90. Alarm is false means P of j given A is 0.95. Similarly, probability that Mary will call when there is an alarm can be also represented by another table. So all this put together, you will be able to, for each of the variable, you will be able to develop conditional probability based on the parents of each and every node. So here for alarm, these two are the parents, and for John the alarm is the parent. So considering connecting all the variables and their interrelationship between them, you will be able to generate the conditional probability of each and every variable. Now you see, the overall probability of occurrence is computed by joint probability, meaning you multiply all conditional probabilities of all the variables available in the network, you will get the overall probability of that particular network. For example, P of j given A, P of m given A, okay, P of A given B and E, P of B, P of E, all of them you take an intersection between them, then you will get the overall probability of the entire network as a whole. So that is what is expressed here. P of x1 xn is a projection of P of xi given its parents xi. That is, for each of the node you compute, and for and the conditional probabilities of all the nodes you multiply, then you will get the probability of occurrence of all those variables which are contained in the network. Okay. So Bayesian networks are well developed representations. Is a directed graph is acrylic graph because directions are required and correspond to random variables. Each node has a conditional distribution given its parents. This is for simplicity. Of course, what is the complexity of computing uncertainty using Bayes network? Generally, it is very simple. Suppose there are 2 to the power of information needed to specify a CPT for a node will be at most 2 to the power of k numbers, so that n into 2 to the power number can specify a complete network. Okay, the full joint contains 2 to the power of n. So for example, suppose we have 20 nodes, n is equal to 20, and every node, for example, there are 5 parents, so k is equal to 5. Then the Bayesian network complexity can be computed as, that means 640 computations are required, which is not a big thing. 640 computations to be done through a computer is not a big issue at all. So the basic task for any probabilistic inference system is to compute the posterior probability distribution for a set of query variables given exact values for some evidences. That is how your network, the Bayes network is of lot of use. There are a lot of advantages of Bayesian network representation. It captures independence and conditional independence where they exist, encodes the relevant portion of the full joint distribution. Entire network you don't need to compute the posterior probability. Joint distribution can be computed considering a portion of the network also to have a good idea of how the network will behave for a particular section of the network. That also you can compute. So with this we have completed a discussion on uncertainty handling, and which is done in terms of Bayes algorithm, Bayes naive classifier, and the Bayes network. There are 3 different ways you can use to compute the uncertainty, and the kind of method that you would use is dependent on the application. So I think with this introduction, with this good understanding of understanding about uncertainty handling is required. Please remember, ability to handle uncertainty is also a kind of intelligence, because there are so many applications where there is an element of uncertainty, and we need to be able to compute that uncertainty and use them as values in either proposition logic or predicate logic in order to build large intelligence, build knowledge, and do different kinds of inferences from that particular knowledge in order to solve different kinds of problems.